All right, here's a quick version of study guide part 1. This is going to be the first 3 pages. I know there was quite a few of you that weren't here Monday when we went over it, which was yesterday. So here we go. I'm not going to hit every problem, but what I am going to do, because you'd be bored with that, what I'm going to do is I'm going to hit 1 in each section and I'm going to jam. All right? In each section, 1 and 2 is a section, 3 and 4 is a section. As you get the study guide, you'll see that. So how do I justify what's going on here? Well, you got to remember, you have to look at what's the pre-image, what's the image, and what transformation occurred. Transformations could be a transformation, reflection, rotation, could be a combination of. If you look at number 1, the figure got bigger, and it wants to know some sort of evidence. So as it got bigger, that's an enlargement. And what's my evidence? Well, my evidence could be my scale factor. The prime notation is it gets bigger. Scale factor is figured out by assessing the length of one line versus another, comparing same to same. So horizontal or vertical, I'm going to compare. I'm going to compare AB, which is 1, 2, 3, 4, 5. That's going to be 5. And remember, scale factor is image over pre-image. So that goes in the bottom because that's a pre-image, over 10, which is equal to 2. So my scale factor is equal to 2. That's it. Done with 1. And number 2, again, keep in mind, if you're going to say, give some sort of evidence as to what happens. Kind of the whole gist of a lot of these different figures is comparing same side. That's how you make the comparison. It's all same. So in here, we want to determine what is my scale factor. Well, I'm going to compare same sides that I know. Pre-image to image. So 15 over 5 is equal to 3. So my scale factor is 3. How do I show my work for this? Well, I want to find x first. 2 times my scale factor should be equal to x. So there's my work. 2 times my scale factor should be equal to x. So in this case, 6 is equal to x. So x is 6. You apply the same process to y, although y comes first. Y times my scale factor should be equal to 9. So y times my scale factor is equal to 9. You should be able to determine what y is. You divide by 3, y is equal to 3. All right, so there you go. There's my work, by the way, right here. There's all my work. All right, so that's that section. If we look here, same thing. I'm going to compare same side. Given the 2 figures are similar, they are similar, it tells me I applied the same thing I just did in number 3, same process. All right, sketch the figure with the dilation of 3 centered at the origin. Which one you want to do? We said here. They give me the diagram. When we did this, originally we started by looking at the center and we drew a line through and we said, hey, 1, 2, 3, and we drew L prime out in space. You don't need to do that. The easier way to do this is to just go ahead and find where all of those pieces are. There's K, there's J, and there's L. So where is K? K is at -1 and +1. And then you would do the same thing with J and L. I'm going to find J, which is at -1, excuse me. L is at, make that look more like an L. L is at +1 and +1. My scale factor, dilation of 3, so everything gets multiplied by 3. Everything gets multiplied by 3. So K prime, sorry, I should have had a little bit better there, and I'm running out of space here, so I'll just do this down here. K prime is going to be -3 and 3, so I go to -3, +3, there's K prime, mark it because it's a diagram. J prime is going to be -3, -3, so I go -3, -3, J prime, and L prime would be 3 and 3, so you go over 3 up 3, boom, 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 there's your diagram. You would do the same process with 8 and 9. By a scale factor of 3, every point gets multiplied by 3, so A prime is going to be what? Well, 2 times 3 is 6, 4 times 3 is 12, so A goes to from 2 and 4 to 6 and 12, same thing. Next section, 10 and 11, compare, same, determine if they're similar. If they're similar, you're going to compare same sides to same sides. So 24 over 12, same sides, top, to left, 18 over 8. If those reduce to the same, they're similar. Solve each proportion, you solve by cross multiplying, you should know how to do that. This one over here, make sure you pay attention to 8 times x, not 8 times x minus 8. Remember, that's how you cross multiply that, is equal to 4 times 2, which is 8. right? Pay attention to that. A lot of students had questions with 15, right? Do one in this section. For 15, what I would do, my suggestion is go ahead and draw the smaller triangle and go ahead and draw the larger triangle, right? If I'm going to look at the chart, larger triangle, which is PRQ, PQ is 3 plus 3, which is 6, right? QR is 12, and this length here, PR, is 22. Now this question's a little off because it's like, find the value of x. Well, there is no x in here. The question mark is what they want you to find. So the question mark ends up being the hypotenuse of the smaller triangle. That leg is 6, and this leg is 3. So now you can compare same. 6 over 3, 22 over x, 12 over 6. All right? You should be able to determine what the scale factor is there. Polygons approaching, are they similar? Again, comparing same. This here, ABC, similar to ARS. You want to compare. You obviously want to jump here and go 33 over 3. That's a comparison you want to make, but double check, AB. AB is the first 2 letters of the first triangle, so I want to compare it with the first 2 letters of the second triangle. AR, AR. So AB to AR. It's not 33 over 3, it's 33 over 11. That is your first comparison there. So you'll get that wrong if you don't compare it correctly. All right? Same thing down here. We had a question on 20. How am I going to determine if they're similar? Well, remember, you have side, angle, side, or angle, similarity. Those are your 3 similarity statements. If I'm looking at 20, it's not going to be SSS because I don't know any sides. Since I don't know any sides, it's not going to be SAS either. Angle is the only one, but I see one angle in one triangle and one angle in the other. You got to remember, these right here are vertical angles. So to back up angle, you know 61 and 61, so you need to make some sort of statement. Angle HTS is congruent to angle. And I went H to T, so I went H to 61. So I go H to 61 again, HGF, and why are those congruent? They are vertical angles. That's why I can make that statement. So now there's my angle similarity. So triangle HGF is similar to triangle HTS by what? By angle similarity. There's your statement, there's your reason. You always have to have a reason for your statement. You should know how to simplify each expression. I'll give you a rundown again. To get rid of the radical out of the denominator, we multiply by the square root of 2, both numerator and denominator. Multiply across. You may not multiply 9 times 2. You can't do that. This is 9 square root of 2, not rad 18. And this becomes rad 4. You can't do that. You cannot multiply a whole number times a decimal. Don't do it. The square root of 4 is a perfect square, so this becomes 9 square root of 2 over 2. 2 won't go into 9, so my answer is done. And then lastly down here, we got to this. This is the bottom of page 3 today. So here's part 1, the end of part 1. For this, you have to remember your algebraic terms. In a 45, 45, 90, and how do I know it's 45? Either the legs are the same or it gives me an angle measure, which it does, it gives me an angle measure. So I know the legs are the same. X, and x squared of 2, right? In this case, B and X are the same. X represents a leg, B is a leg. So if B is a leg and both legs are the same, B is equal to what? Yeah, 2 square root of 2. Why? Because both legs are the same. So you might even put that. Legs are equal, right? I did that. Wow. All right. Now, how do I find A? A is a hypotenuse, and A is equal to X times the square root of 2. But what is X? X is a leg. So if X is a leg, therefore, I'm just simply going to put my X in parentheses, which is 2 square roots of 2 times the square root of 2. Now, how does this work? This works like this. You cannot multiply a whole number of times a radical, but you can multiply radicals times radicals. So what's radical 2 times radical 2? Radical 2, and I'll just do this over here. 2 square root of 2 times square root of 2. And here's what you have. You're going to get progressively down, you're going to get 2 square root of 4. 2 square roots of 4. 4 is a perfect square, so 2 times 2, which is equal to 4. Boom. A equals 4. So there's A, and there is my my leg. So use the algebraic terms for both of these. All right, there's the end of part one. Ask questions if you need to, and be looking forward to part two.